So consider this given problem statement. We need to solve for x for this particular given equation, right? That is 6 over 5 times a to the power this particular exponent, right? That is log of x base a times log a base 10 times log of 5 base a minus 3 to the power log base 10, and in the argument we are having x over 10. This is equal to 9 to the power log of x base 100 plus log of 2 base 4. So now let us see how can we resolve this equation and get the value of x. So definitely we'll be applying the property of logarithms here, right? So we'll just focus on one term at a time. So we know this property, we are aware of this property. Like if you observe this one, that is log of x base a. So this one, or instead of this, if I just focus on these two terms, so here log base a and here sorry, log of a base 10. So this can be written as log of the argument in the numerator, and so instead of this log I'll take natural log of a over natural log of 10, right? Now why did I write this in place of log argument a base 10? So there is a property, that is when I have log of argument and the base is b, we can take an intermediate base given the condition that the logarithmic factor must remain defined. So we can apply natural log of a over natural log of b. You can take any base that keeps my logarithmic factor defined, that's it. So here I've taken natural log, you can take log base 10, you can take log base 9. So whatever is suitable based on application, you can apply that log and write this in intermediate form. So this is one of the identity of logarithms, right? So I'm using that. So on using this one, what will be the benefit you will get to observe right now. Similarly, this log of 5 base a, so instead of this, so this one can be written as log of argument 5 and base here instead of 10, I will be writing a, right? And you can clearly observe this natural log of a is something that is cancelled out. And when I combine this log 5 and this natural log of 10, if I combine this, that means natural log of a over natural log of b. When the logarithmic base is same, then this numerator, the numerator factor, that is argument here, and the base here b, this can be combined in this form, right? So that's the idea. Now minus 3 over this particular quantity. So let us focus on this now, that is 3 over this, the power, right? So 3 to the power this. Now here this one, from division to subtraction we can write, say, right? So for this one, log of x base 10 minus log 10, and this will be argument is 10 and base 10, right? I hope this part is clear. So we have used, that is division to subtraction identity, right? Now this 9 can be written as, I'll just write this expression as it is. Instead of 9, I'll be writing 3 square. Instead of 100 here, I'll write 10 square, and instead of 4, I'll be writing 2 square. So you should not get confused. I'm putting the parenthesis over here. Now I'll be resolving these factors, right, one by one. Now if you observe here, this can be merged as log of base 10 argument 5, right? So here this natural log of a and this natural log of a got cancelled out clearly, and on combining this we can write log of argument 5 and base 10. Now for this one, log of same number, and if the base is same number and the logarithmic factor remains defined, in that case we can write 1 in this case, correct? Now for this part, that is here, that is 10 square. So we know this property. Again, there is a property which says that if I am having something like this, let's say log of argument a power p, and in the base I am having, let us say, that is b power q. So this can be written as p over q, and this will be log of a, that is argument is a, and base is b, right? Base is b. So this is the property that I can use here in this case, right? So instead of this one, what I can do, I can write 1 by 2 here, and this I can write 10 as it is. Similarly for this 2 square, I can write base 2, and this will be 1 over 2. Now from this one, Now I'll proceed to the next step. Now on proceeding towards the next step, if you can observe, this log of 5 base 10 can be written as on the power of this, right, on the power of this. Then if you observe this power and this a, there is a property which says that if you are having the number same number and on this we are having power of log x and the base is same, so this one, right, if I combine with a, so this forms x. So how it goes, I'll just write it in a proper manner so that it is easy to comprehend. So we are having a to the power this, and on the power of this we are having this factor, right. So right now I'm interested in this factor, so this resolves to x when the base in the base and exponent combination and logarithmic argument and base is matching. So in this case I can write simply as x, that means this log base a over here and this a over here, whenever these two are matching we can write simply this one as x. Now from this one we can clearly observe 1 over 2 is the common term and log of 2 base 2 can be written as 1, right. So from this one 1 over 2 and this 2 will multiply and will get cancelled. Now on further resolution, this term entirely becomes x and we are having this one as x power log 5 log of 5 base 10. So to write it clearly, x to the power log of 5 base 10, so I'll write here x to the power log of 5 base 10. So that's the idea, and this half will be eliminated. So this is the given equation. So now you can observe we are having log of 5 base 10 over here and then log of x base 10 we are having, right. And if you observe this part, this 5 over here and this x over here can be exchanged. This is again a property of logarithm, right. So now this 5 and x is something that I'm going to exchange. So instead of x I'll be writing 5 and instead of this I'm writing x, so this we can exchange, right. So this is a property of logarithm actually. Now you can observe log x based on here, log x based on here, and again log x based on here. So this is the repeated term. So what I'll do, I'll assume some other variable for this one. So let u be this particular term which is repeating. Why? So that solving this equation becomes little easier for me, right? So now in this step, instead of this log x based on, I'll write u over here. In this part, I'll write u minus 1 and this would be u plus 1. Now let us try to resolve this equation, right. So for this one, this term will be as it is, and here I will be applying the property of exponent, that is 3 power u and over 3 over here, and in this case as well this one can be written as 3 to the power u times 3, right. Now on resolving this, further, so this subtraction quantity, if I add this on both the side, so this is the equation that I'm going to have. Now from this one we can clearly observe that 3 to the power u is something that is common, that is the common factor, right. So this is the common factor, so here we have written this, and instead of this one I can write simply this one as 1. Now on solving this further, we'll get 6 times this, right, and this one will be 3 power u times equal to 3 power u times this will be 10 over 3. Now on resolving this further, I'll be getting 5 to the power u minus 2, right, because this one can be written as 5 times u minus 1, correct, 5 times, and now this 5 and this 5 gets cancelled, right. This 5 here and this 5 over here can be cancelled out. So again that becomes 6 times 5 to the power u minus 1. Now on resolving this further, and again here also we are having, that is so if I can take here, yes, this one is already u, okay, u minus 1 over here. Now on resolving this one, this surely becomes 5 to the power u minus 2 and this is equal to 3 to the power u minus 2 over here, right. Actually here if I can observe, this is not the right procedure. So what I will do, I'll take this 3 power u and 5 power u together, right, and then try to resolve this part. So from this part, what we can do, so we can write here this one as 5 to the power u as it is, and this would be 3 to the power u, right, and this one I can write this one as 5 5 square, that is 25 over 9, that will be 50 by 18. Yes, so this would be 50 by 50 over 18 on resolving this. So that is 3 6 18, 5 10 is 50, and this one is 18. So again on resolving, this is 25 and this part will be 9, and this can be written as 3 squared, and this one can be written as 5 squared, right. And from this one, if I write 5 over 3, and if the power is u, so from this one the acceptable value for u will be equal to 2. So from this we can say the acceptable value for u will be equal to 2. So we got the value of u as 2. Now this is not the final step. Here we are having this assumption actually. So now since this u is equal to 2 and this one is log x base 10, and from this if I resolve it for x, x is equal to 100. So for this, that is 10 square, so 10 square is 100. So therefore 100 is the solution for this particular problem, right. So I was going wrong in my calculation, but in this part I made it I just made it clear that this 5 power u, so what I have done, I have divided 3 power u on both the sides, right, and then I resolved this expression, that is 6 times 3 is 18, right, and then 5 times 10 is 50. On resolving this we are getting this, and once we get the value of u, so x will be equal to 100 in this case, right. So I hope that should be clear. So we have used multiple logarithmic properties over here, so that is the main essence of this problem.